Okay, so I mentioned to say concentration is defined as amount of solute divided by liters of solvent. We've said solute is just anything that dissolves into the solvent, and solvent is just anything in which you are able to dissolve something. Now, on the types of concentration, we've got molarity, we have got molality. So, if you change the spellings, you change the meaning. You have got also formality, you have got density, you have got parts per million, parts per thousand, parts per billion, parts per trillion. You have got percentage weight by weight, you've got percentage weight by volume, you've got percentage volume by volume. So all these are types of concentration, and we're going to look at them. So specifically today we're interested in understanding molarity. Now the question is, what is molarity? Since we are saying concentration is the amount of solute over liters of solvent, and we know that molarity is one example of concentration. Molarity, the symbol is capital M, never use small m. So molarity is given by the moles of solute divided by the liters of solvent. So make sure that as you are calculating molarity, capital M, which is equal to N over V, the moles are given in mole, that's the SI unit, and then volume should be in liters. This should be the unit. If the volume is not in liters, maybe it's in milliliters, make sure that you get to convert. That's why the first topic that we did was conversions. Convert to the right SI unit. Now we know 1 liter is the same as 1 decimeter cubed. So therefore molarity can also be given as mole per decimeter cubed. So this is the same thing if you see that unit. Okay, understanding that, let's see how we're able to calculate molarity given some questions. Let's say we've been given 11.5 grams of sodium hydroxide, and they have told us that is dissolved in a certain volume of water, is dissolved, let's say, in 1.50 liters of solution. So the question is, what is the molarity? What are we able to do if we want to find the molarity? Well, direct, we know that molarity, capital M, is given by number of moles over volume. And how do you find number of moles if you've been given the mass and the formula? We know that number of moles is given by mass divided by molar mass. So here the mass is 11.5. The molar mass for sodium hydroxide, checking on the periodic table, that is going to give us a 40. And when you get to divide 11.5 divided by 40, that is going to be 0.288 moles. So therefore molarity is going to become number of moles. We found 0.288 moles. The volume, you can see they've given us the volume in which we are dissolving the sodium hydroxide, that is 1.50 liters, and that, punching on your calculator, is going to give about 0.192. So on top you've got mole, down you've got liter, and this unit, which is called mole per liter, is also known as molar. Why? Because we're talking about molarity. Okay, now when you're talking about molarity, after you do the calculations, kg per liter, that will be the unit for molarity, is also called as molar. So this one is going to end with a L on at the end because it's molarity. If you're talking about formality, the unit can also be given as 4 moles. So this is capital M, this is small m, this is capital F. So therefore, you will see most of the times we are going to give the answer 0.192 with a capital M. This capital M meaning molar with an R at the end is the same as mole per liter. If there is an L at the end, that's molar. That is for molarity. It's different from molarity. Okay. Let's work another question. Let's say we've been given 1.56 grams of hydrochloric, not hydrochloric acid, but hydrogen chloride because it's a gas. If it was in aqueous, it would be hydrochloric acid, but it's a gas, that's hydrogen chloride. Let's say this is dissolved in 28, let's say 26.8 milliliters of solution or of solute. The question is, what is going to be the molarity in this case for the hydrochloric acid? The same formula, molarity is given as number of moles over volume. Now we know that number of moles is given by mass over molar mass. And in this case, the mass we've been given, that's 1.56 grams. Molar mass for hydrochloric acid, if you perform the calculation on the periodic table, that is going to give you about 36.46 grams per mole. So if you punch that on the calculator, so you'll be able to get 0.0428 moles. This is the number of moles. Now to determine the molarity, to come back, number of moles 0.0428 moles over volume. Now notice that the volume has been given as what? As in milliliters. So you need to convert to the right SI unit. So the volume is equal to 26.8 milliliters. You want to go to a meter, so remember we have got a milli on top, we're going to put a milliliter down and then a liter on top. A liter is bigger than a milliliter, and you know that in 1 liter we've got 1000 milliliters, so the milliliter will cancel the milliliter. Therefore, would have converted, so the decimal point to move 1 to 3 times, so that would be 0.268 liters. 1 2 no, it will not be 0.2 but 0.0268 liters. So this is the value we are going to use. Make sure that you use the value that is given in liters, not in any other unit. So you have got mole per liter. So if you get to punch this value on your calculator, you should be able to get 1.60 mole per liter. That's molar. So this is going to be the value here. Do you have anyone who is left out? All right. Cool. Now, let's say we've been given 0.50 molar for cobalt nitrate. Now, in this question, we want to find the concentration of each ion in cobalt nitrate. What will be the concentration of each ion? So to be able to find the molarity for each ion, we are going to get the cobalt nitrate. We see how it's going to decompose. So when this decomposes, it's going to decompose into cobalt and also a nitrate. Now we know that a nitrate has a charge of what? -1. The only way these two can come here, it means that this 2 was coming from this compound. That means the valence for this compound is a 2, meaning that this one has got a charge of +2. That is why we can see a 1 here, though you are not able to see the a 1. That means the charge for this one is a 1, which is the one you are able to see there. But because we have got a 2 down here, to be able to balance this reaction, we're going to add a 2 here. So this is the decomposition of cobalt nitrate. Now, if you see, the concentration of cobalt nitrate has been given as 0.50 molar. And there is a 1 in front here, there is also a 1 in front here. If the concentration of this one is 0.5, even the concentration of this one is going to be 0.5. Why? Because they've got the same number of moles. So this will also be 0.50 molar. Now, this one is twice the concentration of cobalt nitrate. So therefore, to get the concentration for the nitrate ion, we are going to multiply 2 by the 0.5. Therefore, this one is a 1.0 molar. So this is the concentration of the nitrate ion. This is the concentration of the cobalt ion. So we found the concentration of each ion. So this question, if they wanted, they would have given us the volume. Okay, let's say this is dissolved in, let's say, in 2 liters of solution. And then the question now, they can ask for us to find the mass of cobalt which are present, or the number of ions of cobalt present. So to be able to find that, let's say if the question was saying find the number of ions of cobalt 2 plus present. To find those number of ions of cobalt 2 plus, remember the relationship between number of ions is with the Avogadro's number, and the relationship with Avogadro's number is with the number of moles. So we need first to determine the number of moles, and we know that molarity is given as number of moles over volume. Let's make number of moles subject the formula, meaning that number of moles is going to be equal to molarity times volume. So here the molarity for the cobalt, we can see that is 0.5. The volume, that's a 2 there. Okay, dissolved in 2 liters. So this is going to give us 0.5, and remember the only way we're multiplying is because the volume is in molarity, and molarity is given as mole per liter. Okay, we are multiplying with liters, the volume that is in liters. So this liter and this liter will cancel. The answer is going to remain in moles. 0.5 times 2, that is a 1 mole. So this is 1 mole. We'll find the moles of cobalt. To find the number of ions, we know that 1 mole of anything, in this case we're talking of cobalt 2 ion, is equal to what? Is equal to the Avogadro's number, which is 6.022 times 10 to the power 23 molecules, ions, particles. Now this question is asking for ions, so 1 mole of cobalt 2 plus is equal to 6.022 times 10 to the power 23 ions, and this is 1 mole. So if it wasn't 1 mole, let's say if it was 2 moles, we would have now said 2 moles is going to be equal to x. So now we find the what? The x. If the question asked us to determine the mass of the cobalt, how would we have found that? We know that number of moles is given by mass over molar mass. Okay, the number of moles here we've calculated as 1, so we'd put 1 here, and that would be equal to mass, which we will not know, over molar mass. Molar mass for cobalt easily determined from the periodic table, so get a molar mass from the periodic table. So therefore the mass will simply be 1 multiplied by the molar mass, which is on the periodic table. Using this, you would have found what? The mass for the cobalt 2 plus ions which are present in the solution. So this is how you are able to work out calculations on molarity. Now, using this same knowledge which is present here, You need to know that number of moles of a substance doesn't change even when you get to add water. For example, here is your cup, you add sugar to this cup. These are the particles that are going to be in that cup. And then in the same cup, you also have it like that. So if this is the cup that you have, you add water up to this level. You add the water to that level. Maybe it is too saturated. It is super saturated, meaning it is too sweet. If you add more water for the water to reach at that point, the number of sugar particles which are present in the water remains the same. So number of moles is constant. Why? The only thing that you are changing is what? Volume. You are only adding more water or removing water, but the number of moles of what you've dissolved or the number of moles of solute remains the same. So even after you dilute, you see the level here was at this point, this was V1, but now the level is higher. That's what? V2. But the number of moles you can see is what? The same. So because of the dilution, when you have more volume of water as compared to the number of particles, the concentration is going to be reduced. Think of this. When you have got little water but more sugar, this cup is going to be much sweet. But when you add more water, meaning that the volume has increased, the sweetness is going to reduce. That sweetness is what we call concentration. So the concentration reduces when the volume is more, but the number of moles still remains the same. So from here you can see that number of moles that we started with is equal to number of moles that we are going to end with. So we say N1 is equal to N2. But from the formula we know that molarity is given by concentration. Molarity is concentration given by number of moles over volume. To make number of moles subject the formula, number of moles is going to be molarity times volume. So where there is number of moles 1, we are going to put molarity 1 times volume 1. And that will be equal to where there is number of moles 2, we're going to put molarity 2 times volume 2. Like that. Okay. So this is the dilution equation formula. It's very, very important. All operations that you are going to be working with, you are going to put that into consideration. So how can you apply this equation now? So the only thing that changes when you're adding water to something is the molarity or the concentration and also the volume, but the number of moles of particles still remains the same. So let's say you've been given 16 molar of sulfuric acid. And to this 16 molar of sulfuric acid, you get to add water. Okay, you add water, and the final volume after you adding water is now 1.5 liters. Okay, so what you have added is 1.5 liters of 0.16 molar sulfuric acid. Now the question is, what is the volume of sulfuric acid here? So the thing is this: you have got sulfuric acid. This is the first sulfuric acid that you have, and then you get to add water. Okay, when you add water, you can see the final volume is this one, and then the final concentration is that one. So this one you've been given is the initial concentration. You don't know the volume. That's what you want to find. But after you add water, it gives you that the water is going to go up to 1.5 liters, and the concentration, you see, it has moved from being 16 to what? To being 0.16. Why is it gone to 0.16? Because you have added more water. You have diluted the thing. Whenever you dilute, concentration reduces. Now the question is, what volume of water, or what was the volume of the sulfuric acid before the addition of the water? So you say from the dilution equation formula, M1 V1 is equal to M2 V2. So M1, that is the first molarity, that's the one you've been given, 16 times V1. So if the molarity is 16, then the volume is going to be V1. But when you get to dilute, the molarity becomes 0.16, then the volume is going to be 1.5. Make sure that the units are correlating. This should always be in liters, this should always be in molar or mole per liter. Now I want to remain with V1. What should be the volume such that the molarity should be 16? So divide both sides by 16. The volume therefore is going to be about 0.0094 liters, which we can also convert to milliliters. Just multiply by 1000 and that would be 9.4 milliliters. So how do these terms relate? You see that if the concentration is high, the concentration is 16, the volume is so small, 0.00. But see, when the concentration is small, 0.16, the volume is much bigger than the what? Than the 0.09. So these things, when one moves up, the other one is going to move down. When the other one increases, the other one reduces. This is about the dilution equation. So dilution is very important because given chemicals, when you get chemicals in a lab, most of the chemicals are very dangerous, and so to be able to work with them, you need to make sure that you get to dilute them to a certain concentration. So for you to dilute them to a certain concentration, you need to understand, okay, if I've got a 2.5 liters of hydrochloric acid, and on the paper there they've written that its concentration, let's say, is 5 molar. Now I just want to use 1 liter of solution. What will be the concentration that is going to be there? Or for example, no, this concentration is too big. 5 molar is too big. Let's have a concentration of 0.2 because we want to use in a laboratory. So how much water should I add to this uh, hydrochloric acid that I have so that I get to have this concentration? So I'm going to calculate the volume of liquid that you need to add to that. So that's how you get to apply the dilution equation.